Hi, I'm Maarten van der Perre. I'm a senior specialist solution architect in app development and a bit of AI within Red Hat. Today we're going to talk about software templates, microservice designs, and how to maintain them from a centralized point of view. If you want to hear more about platform engineering, AI, development practices from Red Hat or in general, feel free to go and visit maartenvandeperre.be, where I have a section with blogs and latest recordings of talks, for example, at developer conferences. But back to the content of today. What are the issues we are facing? What are the issues we want to solve? Well, first of all, I'm talking a lot about platform engineering, developer portals like Backstage, and they solve an issue that's related to microservice design and software development in general. Think about the bookmark hell. What is the bookmark hell? Well, imagine you have to traverse through your entire IT landscape. You need to think about all these CI pipelines for the microservices, mini services that you're developing. All these services have deployment pipelines as well. You have documentation scattered around in Teams, GitHub, Confluence, SharePoint, and so on. To find your way in an efficient way through the entire landscape requires to bookmark all these pages. And this is what we call a bookmark hell. A bookmark hell is going to be solved by a developer portal, which brings a single pane of glass, one single view on top of this landscape. One portal can be Developer Hub, which is the productized version of Backstage from Red Hat. If you want to hear or see more of it, feel free to check out the talks section on my website. I have quite some recordings around platform engineering and dev conferences, for example, DevOps Belgium, where we have a demo of Backstage on top of Kubernetes OpenShift. A big advantage that these portals bring is that they have the concept of software templates, sometimes called scaffolding templates as well, because it can go beyond the scope of just software templates. What is a software template? It's a skeleton where you have default application, a standardized starting point of an application from where you can start from. A developer then bootstraps this template, which will result in a project created in his Git repository or her Git repository, and from where on you can start coding. One big disadvantage of this, it's a bit inherited through the microservice mini-service design, is that you don't have a centralized point anymore in maintaining these applications. Let's say, for example, we have 5 microservices started from the same Quarkus software template, or Micronaut or good old Spring Boot. Then if we want to upgrade the Quarkus runtime, we have to update 5 applications, 5 repositories, which can become quite fast a maintenance burden, a maintenance hurdle. So it would be cool to have now a centralized way in organizing these kinds of upgrades, without, preferably, touching on the isolation paradigm that goes along with microservices, mini-services. One way is to work with the pull request store, where you, for example, keep track in a registry of which applications got bootstrapped from which template, and that whenever you change the template that you broadcast pull request storm to these applications repositories. We won't go more in detail into this topic today. Today we will focus on a topic which includes software coding, software principles named clean architecture. If you're not familiar with clean architecture, feel free as well to read this blog post. You can find a link through the website too. But in a nutshell, what is it about? Well, instead of having the original lasagna layered approach of service-oriented design, you now go to a more onion layered approach, which is similar to, for example, hexagonal development. The core of the onion is the blue layer, where you have a domain model and use cases. It originates from domain-driven design, where you, for example, have user commands. Well, you can see, if you're not familiar with it, these use cases as domain-driven design commands. And then domain model is just the data storage, data concepts, the data API of all the domain objects that are existing there within your application. Within the blue, so the dark blue and the light blue region, it is important that you don't have external dependencies, because this is where your business logic resides, this is where your domain model resides, and it should not be affected of, for example, dependency upgrades. Then you have the orange layer, which can be multiple layers in practice, in which you, or through which you inject databases, external libraries, file systems, and so on. These, of course, can contain external libraries. And then in the greenish layer, should have thought the color a bit better to be honest, you have the glue. This is now wiring everything together in an artifact that can be run. For example, a Quarkus application, a Spring Boot application, serverless functions, and so on. Over here, you see multiple applications, multiple artifacts that can be deployed. Now, because we're using this code base in different ways, for example, you have the monolith in Quarkus, and let's say some for batch processing, serverless functions extracted out of this code base. If you're using Quarkus, one of the advantages is that you have that code removal. So all these APIs, libraries that you're not using in, for example, serverless function 2, will be removed from the resulting artifact, the resulting binary, which can be optimal for example, deployments on Kubernetes. But how is this now going to solve our issue that we have with no centralized way of managing dependencies, for example, or generic APIs? Well, for this, let's go to the code. I've created a software template. In Kotlin, can be Java, can be .NET, can be Python. Doesn't matter too much, to be honest. It's important that you understand the thinking, the reasoning behind it. So it's a Gradle project, could have been a Maven project too, in which we have the platform, which is nothing more than just deciding on which versions we have. And I have, for example, the Quarkus, which is then linked to the Quarkus version. We have one for Open Liberty, we have one for Spring. Just Gradle dependency management, nothing exotic about this. And we have a parent application class project. Remember the clean architecture onion layer? Well, in the core layer, we have utility classes, we have domain, and we have use cases. One is, for example, a response class, and no use case implemented yet. We have data providers, which can contain code, for example, to connect to databases. And we have a glue that glues everything together. Over here, to showcase you what can be done with such way of organizing your structure, I already implemented an Open Liberty configuration and Quarkus configuration, so that the end user, in the end, will be able to choose the underlying runtime for his or her application. Because often APIs are part of the runtime modules as well in the clean architecture parts. No, it's not because because was the wrong word. Often APIs, for example, REST APIs, because they're bound to the language of the runtime, let's say, for example, Spring Boot annotations. REST APIs are part of the configuration modules. But this is a bit an anti-pattern because, if you're working with multiple runtimes, you would need to copy over these APIs. So that's the reason why I, over here, created an extra module with REST endpoints. We're binding to Jakarta spec, which luckily is already supported by Quarkus and Open Liberty, which stick to the standards. We should have some work to get this Spring Boot compliant as well. But for the sake of ease, we just go with Jakarta endpoints over here. This is just the application, nothing more than this. And this will be the parent from which our new microservices will be able to start. How can we start new microservice out of this? Well, for this, I've created some scripts. And let's first execute them and then see what these scripts will be doing. For this, I will create a new project, temp demo, new window. And let me drag in IntelliJ to the correct screen. Okay, I don't need Java for now. And let's kick off the Bootstrap script. What is this script going to do? Well, we will use Git submodules in order to do maintenance with these parent templates. It will drag in the parent template project in one of the submodules, create a second hidden layer where we already do some manipulations for this project within the code base, and next to that, it will then create new modules which can be injected to the parent application it's getting dragged into the Git submodules so that we can enable our new sources, so that we can enable our new code. So this is test demo project. Okay, and the code is there. So what do we see? We have the submodules, which is just the parent application project, which is now dragged in. We've done minor changes, but we did some changes, for example, on the Gradle settings to enable it in this project. From here on, we link from our application code to the code from the software parent. Whenever we update the Git submodule, these updates are getting dragged in into the submodules project, which can be referenced from our code base. So this is now a part of the application we are developing. In the application folder now, we can create the code that we want in order to deliver this specific business logic. For example, an order API that we want to build. Through the script, we already have one default endpoint, which is just, no fooling around. We will start API development over here. Okay, cool. Let's see if the application is already starting. So for this, Gateway monolith help. Yep. Should maybe just have called it help, but I ran into issues with Gradle help functionality, so I called it monolith help because we're still developing a little monolith over here. Could be microservice help, or however you want to name it. If we now check out, we have starters to start in Spring Boot, in Quarkus, and we have starters to start in OpenLiberty as well. By default, based upon the property, it would be Quarkus unless you change the property to OpenLiberty, but we'll make it a little bit more explicit. And let's start the monolith in Quarkus mode. Important thing is if we want to try it out, and let me go back to the template parent, in order to show you that we changed from runtime, I had the application context from Quarkus on /Maarten, I think, and from OpenLiberty on /Maarten-monoliths. But we can find out over here as well. Because the curl commands to test were part of the help documentation. So we will be able to see indeed Maarten-monolith for Quarkus /monolith on the path for OpenLiberty. So Quarkus did start. We're starting it in the dev mode, which means that we have a dev UI to play with, which is as well one of the benefits of Quarkus next to the performance and the smaller artifacts, smaller images that are resulting out of it. You have a better developer experience than any other Java framework that's out there, especially now a cloud native Java runtime. So let's check it out. Okay, we have the dev UI, we have a dummy and a hello endpoint. Where do these come from? Well, the dummy endpoint is the one in our current code base where we can start developing. let's say no hello demo. Wait, 1 second, that was a bit too fast. So in the dummy parts, no hello. Let's show you the live reloading, hot reloading from Quarkus. So no hello demo. I refresh the page. It is changed, so it's updated. So that's already okay. And let's say, yeah, the other endpoint, sorry, going back. The slash API hello is coming from the parent template. Well, for this, let's go to the template and show you where it comes from. It's hello from REST easy reactive. Well, let's say, hey, hello from demo. And let's now imagine that this is a generic endpoint that all of our microservices should use. For example, security, something observability or monitoring related. Well, we now push this out. And indeed, maybe create a second class, second endpoint. Say buy, and it's a buy resource and buy from demo. So we commit and push. And now the parent project, the parent template is updated. Well, if we now go back to the child template and I quickly stop Quarkus here, we have an update script to update the parents. So let's run this. And what it will do, it will update the Git submodules and link it to the current code base. Okay, so far the update was okay. Let's start Quarkus again. And we should see that the new endpoints and the changed endpoints should be part of the application stack now. So let's go back here. Let's reload the dev UI. We have buy and hello, so the new endpoint is already picked up. Let's go to hello, it's the updated one. Let's go to the buy endpoint and we have buy from demo. Okay, cool. But in the parent update, in the parent project, the parent application, we had 2 runtimes. So let's stop Quarkus and let's now start an Open Liberty, which is another Java runtime, cloud native Java runtime. Okay, let's kickstart this one. And this can be, for example, if you're migrating away from Spring Boot to a cloud native Java framework like Quarkus, then you could say, hey, for now we support both Spring Boot and Quarkus. We add Quarkus in the runtimes folder, new property. You can start developing in Quarkus already. And then in a later stage, for example, you can remove Micronaut Spring Boot if you want to stick with only Quarkus. There's already a way on enabling Java runtimes next to the ones that are running at the moment to modernize the entire application landscape. Let's now check out the endpoints in Open Liberty. No hello demo. Okay, so that's there. And we have the Open Liberty project running, so it's not Quarkus that's there. If we now go to buy from demo, so the new endpoint is available over here. But let's say we made a mistake. This endpoint should not be available within all our applications. Well, we do a revert of what we've done so far in the parent application. So revert goodbye resource, commit and push. We're pushing our update in the parent, which could be as well an update of the Quarkus version, an upgrade of the Open Liberty platform, code changes, generic endpoints that are required for applications, and so on. So changes pushed. We go back to our child application. We stop the Open Liberty application. Beware, I call it monolith. Could have been mini service, microservice. I just had to give it a name, and I chose for monolith because it's a single application. But feel free to give it better names because in a microservice landscape, everybody is allergic to monolith as a name, right? Everything is on GitHub, as you've seen as well already. So feel free to update the naming to have better matching names here. So we've updated the project. Let's start again in Open Liberty. And it's starting. And we now should get a 404 when we're trying to access this by endpoint. And it's not visible anymore. Cool, it's removed from Open Liberty. And for the sake of completeness, let's check in Quarkus as well if it's still there. And while it's starting, let's say we have to create a new endpoint within our Java, in our Quarkus application. Well, we have the dummy. Let's do new demo endpoint. So new business logic that we have to start developing nowadays. We don't need to care about the Quarkus runtime, the Open Liberty runtime. It's set up for us and maintained for us through the parent project. If we want to isolate it completely, if we really want to cut it off of the parent project, well, it's simple. Don't run the script anymore. And you have an isolated code base which can run on its own. So you have a soft link, a soft dependency on the parent project, but in the end, in practice, I don't think that will ever be the case or ever be a requirement. And now let's see how it looks like in the dev UI, which endpoints we have at our disposal. Oh, I made a mistake. Ah, yeah, sorry, I forgot to rename the class name here, demo resource. We don't need to restart Quarkus because the hot reloading. And you see we have the new endpoint over here, we have hello, and the endpoint from the parent application got removed. We can check this in and we can start developing our business logic without the hassle of a couple of days to start with a new application. And with this we have as well a centralized location from the parent project to update runtime versions, dependencies, generic shared endpoints, and so on. If you want to play with it yourself, feel free to check it out. It's on GitHub on this link, and it will be referenced to on my newest blog post, which will be part of the Red Hat developer documentation too, and which will be linked through my website, maartenvandeperre.be. I hope you enjoyed this demo and see you for the next one. Bye.